Hey guys, welcome back again. I hope you are doing well. So let's see today's LeetCode and GFG question. Okay, Robert needs loaded. Open. Okay, let's open it. So what is the question? Given an array integer of R and an integer D, in one step you can jump from index I to index I plus x, where I plus x is less than the length and also it should be less than equal to the t given below in a given above, and I minus x same, it should not go less than 0. In addition, you can only jump from index I to index j if index I is greater than, whatever the array of I is greater than the array of j, and array of I is greater than array of k for all the k between I and j. More formally, minimum of ij to maximum of ij. Okay, you can choose any index of the array and start jumping. Return the maximum number of indices you can visit. Okay. Notice that you can jump outside the array at any time. So here's the output is 4. Given that d is equal to 2, let's see how it works. You can start at index 10. You can jump index 8, 7, 8, 6, 7. First 8, then 6, and then 7 as shown. Notice that if you jump at index 6, you can only jump to index 7. You can jump to index 5. You cannot jump to index 5 because 13 is greater than uh, 9. You cannot jump to index 4 because where is 4? Okay. Because index 5 is between 4 and 6, and 13 is greater than 9. Similarly, you cannot jump to index 3 to the index from index 3 to 2 because or index 1. Okay, so as for my understanding, uh, in addition, you can only jump to I index. This is very important. Okay, एक तो हम index I example, just a big one, we can jump to the index 8, also 9. Okay. If we had jumped on the 9, then we cannot probably go to the 9, the 7, because the 10 index 8, which has 10 in between. So, okay, the question is not too much, uh, you know, I'm not clearly understand this question. Uh, why? Because this is what I'm saying. We can jump uh, from index I to index if we have these conditions. In addition, we can only jump to index I to j. Is that meaning uh, in addition that whatever? Uh, Probably I'm thinking too much. Let's try how we can solve this question. So let's try recursive way. Okay, that we can. Okay, we have first option to go from every uh, so we have the distance, right? 0 to that distance we can jump either the left or the right, right? And uh, whenever we are jumping, we have to make sure that this passes. Okay, what's the constraints? It's low, so probably we can go with the recursive way and try to implement DB after. So let's try. So what I want is first it's pretty much clear that uh, whatever the jumps you can. Mm, okay, let me think how I can solve this problem. Let's take a screenshot, okay, and try to analyze. Okay, so there's one thing which is we have this distance d, right? We can start at any index, meaning we have to try every index. First thing that is noticed, we have to try every index as a starting. So, and later, uh, whenever we try to jump, we can do at least, at this much distance. If I am understanding the question, okay, we cannot exceed this either 0 to uh, less than distance, right? We can go this much steps either next or previous. Mm, let's say we are going either this or this direction, then let's say if I jump on the 10th, okay, if we are jump at the 10th, then either we can go to 7 or 9, okay. If we uh, go at the 7, we have no direction to go, okay. So it's pretty much like, let's see, I'm getting something now. If we are jump at the 10th, okay, let's say, Then if we go on the first seven, then we have no direction to go because this one is greater, this one is also greater, right? So and so for this, it's only one that we can go, right? Our output is fourth, which is first, second, third, and the starting fourth, I guess. Let's see. 10th to 8th, 8th to 6, and 6 to 7, right? So, uh, you know, we go this, then it has only one direction to go. Now, if we go on this, then this can go to this, which has already mentioned I1, then this will be 2. Okay. And when we start directly at 9, then probably we end up with having 2 only, right? So, yes, now I'm getting some sort of things. Uh, we have to try for every index. That is very much clear, right? Uh, Let me do one thing that select this, minimize it. Okay. So one thing is clear that we have to try every possible, and also make sure that what is this? Okay. Uh, we will have recursive for uh, for jumps. This much jumps we can do, right? From every index, and let's say I started from index I. I started from index I, and then there will be uh, this is the distance, right? 1, 2. So either for every index we can do these much jumps, right? And obviously we will have the array. Okay. So this is our function probably. Then for uh, index plus uh, you know let's say try to j is equal to 0 to b, then we can call this function like I plus j. It will be like 1 to b, I plus j, and again d. Okay, the function. And also we can jump to I minus j to b. We will check if it's valid or not. Okay, not out of boundary. Let's say we are on this. Okay, and we can jump either 9 or 8, right? Index wise. Then if you have 9, then we cannot jump other directions, right? And this will have its value, which is 1. Okay. Then it's a confusion now. How can I solve this problem? There is one thing clear that we can jump. Now, for every jump, we have to check that Okay, now I'm getting one thing that, when we call for this, meaning we are trying to understand if we are on this, okay, let me do. If we are on this, then where we can jump, okay, either we can jump to this, we can jump to this, we can jump to this, right? So for j is equal to 1 to b, okay, we have to check for it's a valid step or not, okay. If valid, no, if safe, then if safe, then we can jump to this, okay. And you can see this is safe for this one and also this one. So else, if it's not safe to jump, then probably uh, not hang out. But if we already jumped on this part, okay, that meaning our currently count is one, meaning we are reached at this, right? And and C and D plus equal to, because this will give us a count where it can reach, and then return the count. Now, most important, it's the safe function. Uh, we cannot jump. Uh, we cannot jump as much we want. Like we can jump on this or this. No, we can jump either one index, which gives us the max. So if instead of doing plus plus, we have to just check the maximum among these. Okay, and then count one plus the maximum whatever we get. Okay. Now it sort of looks good. Let's try. We can have the int solve initially, which will have the array, the distance, and also the index, right? ID box, and our this will be max jumps we can get. Okay, and for int I is equal to 1 to I is d less than equal to d plus plus I. Now if it's safe to jump uh, the index idx plus I, the next direction, then if it's safe, then we will have like max jumps, max, sorry, max jumps, or uh, you know solve for AR height. That's yeah, height. Also, we have to uh, let me think. Okay, let's try. If it's safe, and if plus one, and then you know distance, whatever it gets. Either we can do this, or we can go with this minus. Okay, whatever the max we get, we have to become 1 plus the max jumps. Okay, and now about the each cell having index. Okay, first we need start the in plan. So we need for the IDX and then jump IDX and then the jump. Okay, so IDX then jump right for in I is equal to 0, so I is less than and not 0 but it should start and it should be n plus plus 9. So we are actually on it, right? So we have to make sure that as if start will be always good, but we have to check end. This is start, right? And end. So whenever we are trying to jump, we have to make sure that array of I should be greater than array of j. Okay. So meaning we have to pass this, but also the direction. Let's say direction one going this direction and -1 for going this direction. So we need direction also. So if start is less than 0 or start is greater than equal to time or n is less than 0 or is greater than equal to we have a dot sign. It's not a true or a false. Now let me think. Our direction. If it's 1, then we are going this direction, right? So if the is equal to 1, we are going this direction. So we have to check for uh, we have to check for this condition. AR of I should be greater than AR of J. So here we are going from start plus 1. Start plus 1 to end. If it's less than equal to that, then false. We are going from uh, start to end. Minus minus. If start is less than equal to other 5, then false. Otherwise return it. Okay. So it's safe, it's good now. Then, uh, okay. First, let's say we are on the index 10, then we go to the index 9, okay? Then this will, it tries to go either left or right, but not happening. So it will return 1. We go on the 10, we'll check right or left. Then it uh, goes for the 7th and the 9th. Then 7th will return 1. But if we go on the 9th, then it will return 2. And then it goes to 10, 10 will return this, and this will return this. Let's try this and try to debug later. So, array distance. And let's start with starting from earlier. Uh, the length minus 1. Probably it should pass this first test case at, at least. So it is giving two answers. It is giving 1. It is giving 1. So if we are on the 12, okay, then our start is 12. Uh, Now its start is less than equal to the maximum jumps. Let's try to see what is happening, where we are going. We have to track it. 'Out of bound', meaning that the 11th is out of bound or length 1. 11, we have to just uh, think about what's index. So it goes for 10, then it goes for 11. But why this is going safe? Probably this is something like we have to check. Yeah, okay. Okay. If start is less than zero, or end is less than zero, or start is greater than equal to end, or end is greater than equal to end, return false immediate. Now, if direction is greater than one, zero meaning we are going from this to this. So, in I before to start plus one, I is less than equal to end plus I. If here start is less than equal to and return false, that is I is equal to start minus one. I is greater than equal to n plus minus I. In here start is okay. Still calling for 31,730. Yes. Okay. Okay. So if this is set, it should be minus one. Okay. So it's passed. At least our first test, yes. We designed for this one or all only. Let's try for everyone. It is passing. Now let's try to apply it. Since there are two things are changing. Okay. I'll take two DD the N and then distance D plus one. Okay. Then we probably put the TP here, then we probably accept TP here if TP of IDX T is not equal to 0, and that TP of IDX T. Okay, and also pass TP here, also pass TP here. Okay, now these are the jumps. IDX and T. These are the jumps that we can think of. Let's see TP will work or not. We have to pass. First, we go on the 9, then it stores their answer. Then we go on the 8, then it stores their answer, which is it goes to the 9 and then 7, and then 7 stores its answer, then 9 stores the answer, then 10 stores its answer. Then it goes for 13. When it goes to the 9, then it will store the ninth answer. Then if you go on the 8, you can go to the 6. They can show their answers. Since we are not adding the answer, probably it should work. Just try to submit. It's accepted. Okay. Now we have to optimize it, but we can do later. I mean, I can do later. You have to, think about the optimization. Let's try the GFG. Last point in the key of alternatives. Representing the values of points arranged in the row. Two players play the game by picking the points alternatively. At each turn, the player can pick the point from either of the beginning or the end of the array. Both players follow greedy strategy. They pick the coin with the maximum value among the two sides available. Hence, the game continues until only one coin remains. Okay. तो पहले 9 पिक कर लिया, फिर 6, फिर 3, फिर 5, फिर 3, फिर the output is 1. Okay. 5, you can pick 5, pick 9, 2, 11. अगर ये ग्रीडी स्ट्रैटेजी से ले रहे हैं तो आई थिंक जो सबसे स्मॉल रहे वही रहेगा. आई थिंक the remaining point will be the small among these. No, maybe the smallest are on the starting. They have to pick for. So how they can solve this question? Okay, 5, 9. Set chooses time. Let's try low 0.5 layer of length minus 1. Okay. Is there anything that I should know? No. We have at least one size while low is less than high. Okay. And at last return area. And uh, if area of low less than area of high, step to back again and minus minus. Else low plus plus. So it is working. So yeah, it is good. So yeah, thank you for watching, and yeah, bye bye.